Hello friends, good day. Today we will be talking about triplet of order 10 moles. It's a topic from Latin square, Greco-Latin square. So what is a Latin square? A Latin square of order n is an n by n array filled with n symbols, each appearing once per row and column. So in every row and every column there will be all symbols, or there should not be any duplicate in any symbol or in any color. Then two Latin squares are called orthogonal if all n squared ordered pairs are distinct when superimposed. When we superimpose two Latin square of the same size, if all the pairs appear, then they are called orthogonal. And then what is a triplet? A triplet of moles means three Latin square pairwise orthogonal. Every two of them are orthogonal. That's a triplet. So this is a mutually orthogonal Latin square or a Greco-Latin square of order 3. Both are 3 by 3 Latin squares. There is no duplicate in any row or in any column in any color. And if I superimpose the first Latin square on the second Latin square, we get all the 9 pairs, all the n square pairs. Green, green, yellow, yellow, red, red, yellow, red, red, green, green, yellow, red, yellow, green, red, yellow, green. So all 9 pairs are there. That's why they are called mutually orthogonal. This is a mutually orthogonal uh, Latin squares of order 4. Each one is a Latin square. There is no duplicate in any row or in any column. And if we superimpose any two of them, there are 3 pairs. If we superimpose any two of them, all the 16 combinations appear. It's a nice brain teaser to construct a mutually orthogonal Latin square of order 4. This is called a complete set because we have a theorem for any order n. There could be at most n minus 1 mutually orthogonal Latin squares, and this is provable logically or mathematically, but I am not going into the proof. So this is a complete set of moles of order 4. It's a nice brain teaser to try to construct them. Why moles are important? Important in design theory, orthogonal arrays, finite projection and affine planes. I know nothing about it. Applications in error correcting codes and experimental designs, appear in cryptography and combinatorial constructions. This is a part of combinatorial mathematics, Latin square and Greco-Latin squares. Some general result: if Q is a prime power, there exists Q minus 1 mutually orthogonal Latin square of order Q. If Q is a prime power, then Galois Q exists, and we can construct can construct the complete set of mutually orthogonal Latin square of order U for order Q. For n equal to 6, no orthogonal pair exists. Euler faced this problem while tackling the 36 officers problem, and he failed. Later in 1901, French mathematician Gaston Terry proved that for order 6 there is no orthogonal pair by complete exhaustion of cases. For n equal to 10, 10 is not a prime power. It can be factorized by 2 into 5. Situation is special, and because 10 is not a prime power. Status of order 10: orthogonal pairs of Latin square of order 10 exist. Then ChatGPT, I gave the instruction to ChatGPT to create these slides for me, and it created, and ChatGPT came up with a statement: a triplet does not exist. Maximum of n10 equal to 2. n10 is number of mutually orthogonal Latin squares of order 10. That is number 2. Consequence: no orthogonal array OA 100, 5, 10, 2 can arise from a triplet of order 10. But today when I gave the same search to ChatGPT, it says that orthogonal pair, whether a triplet exists or not, is still an open problem. However, ChatGPT gave its support towards this statement. He refers to these papers, R. A. Mathon and in Rosa, Two Designs of Small Order, Annals of Discrete Mathematics, 1987, then C. J. Colbord and J. H. Danzig, Handbook of Combinatorial Design. I don't have resource to check these papers, but I believe ChatGPT is wrong. Now let us talk about moles of order 10. This is a mutually orthogonal Latin square or Draco Latin square of order 10. There are 10 colors and there is no duplicate in any row or in any column in any color for the big box as well as the small box. And there are 100 big box small box combinations. So this is a Greco Latin square or mutually orthogonal Latin square of order 10. Then ChatGPT came up with a simple formula for the construction of order 10 mutually orthogonal Latin square, but this is not correct. I tried to follow it to construct an orthogonal mutually orthogonal Latin square of order 10, but this method doesn't work. And ChatGPT gave its support why the pair works because based on modular arithmetic in Z2 and Z5. I think ChatGPT is assuming that quadratic square of order 2 exists, which is untrue. We have got the 1959 paper by both Seconde and Parker, where they prove that orthogonal Latin squares, mutually orthogonal Latin squares, the pair exists for all orders except 2 and 6. This is a famous theorem. Different coefficients of 1 and 2, and ChatGPT tries to give support to its statement that triplet doesn't exist, which is wrong. So how far could we go? We have the examples of the near miss. Computational searches found near misses 3 Latin squares almost orthogonal. 2 pairs are perfectly orthogonal, where the third one has 9 repeated pairs out of 100. Useful of approximate designs but not true moles, shows how close the 10 or order 10 comes to supporting the true triplet. So there are near misses, and here is an example of the near misses. We have a triplet of 10 where all three are order 10 Latin squares. There is no duplicate in any row or in any column in any symbol, and first and second Latin squares are orthogonal. First and third Latin squares are orthogonal. Second and third fail to orthogonal because we have found duplicates. I have colored the cells. 6 1 comes here, 6 1 repeats here. So there are shortage of n square entries, and the reference is J again and I am Walnes. Enumeration of moles of small order, Mathematics of Computation, volume 85. So we have got the reference, and this is the farthest we could go. Still, I think I believe the triplet exists and it's an open problem. And here are the ladies from UK working in hospital with their mother, and that's a triplet. This entire talk is based on is documented by ChatGPT. I gave a single line instruction, triplet of order 10 mutually orthogonal Latin square, and ChatGPT gave me this example, but it has its errors. I'll stop here. Thank you. Like, comment, share, subscribe my video. I am available for one-to-one sessions too. Thank you.